Okay, how's everybody doing today?
Good.
Right, my name is Mike McLaughlin. I'm going to get into a presentation here in a minute. I just had something running on the screen here. If you've had a chance to look at it, we're going to talk about this a little bit later. It's basically the topic that I'm going to be looking at today, or presenting our solution around. The solution is around the desktop virtualization. All right, a couple of housekeeping things. The swag that we were going to bring, the hats and stuff, didn't make it here.
Uh-oh.
But I do have an Apple Watch here
Ooh.
that we're going to raffle out with this handy little tool. So if you could throw a business card in here, that'd be great. I put mine in the bottom. All right, so I sort of loaded the deck here. But if you don't have a business card, feel free to pull one of these out and write yours on the back.
Okay.
We'll pull one out at the end of the presentation for the Apple Watch. And if it's mine, I'll throw it back in and pull another one out. But I just want to pass this around and start this over this way. And as I'm talking, you can just, if you're interested in the drawing or my business card, grab it out of there. This particular little video that's playing here is called, I call it Desktops at Play. And it's indicative of something that happens in our environments as we do a lot of testing. I'm going to go ahead and stop this for now and switch over to the topic of conversation for today. And that is basically a Datrium solution for desktop virtualization, VDI, end user computing. It has a lot of different sort of names that it goes by these days. And what we're going to look at is essentially a solution that we're calling open convergence. All right, so a quick show of hands. How many people understand hyperconverged? Great. And obviously, converged infrastructure is a traditional server, SAN, storage-based solution. I'm guessing most of you are familiar with that. Many people have flash in their data center. All right, that's a good sign, too. Looks like about half up there. All right. So this might make a good sense to you then as we get through. Just a couple of minutes for the company background. Since they flew me out here, I want to kind of make sure you know who we are. So Datrium, we're founded by some senior architects and engineers from VMware and Data Domain. All right. So essentially a blend of virtualization and storage management came together to put together this solution that we have today. We're selling it in the US, Canada, and Japan. All right, and what we're calling this is open converged. All right, and I'll explain what that means in just a little bit. Server-powered storage might be another one. It's not quite hyper-converged, so the fact that you do have some hyper-converged sort of knowledge and experience or background is going to make this fairly interesting. We started really selling product earlier this year, back in the January, February timeframe. A couple of interesting marketing awards and whatnot. It's been a really good year. We've got a lot of interested customers, a lot of success in what we're doing. But it's based on a simple premise. Is flash came into the data center several years ago. All right, we started to see it in the hybrid arrays and the all-flash arrays, as cache accelerators. It's had a significant impact, but it's been pretty much delivered from the storage vendor side of things. All right, at storage vendor architectures and storage vendor costs. And what we've seen is an evolution over the last couple of years, particularly with hyperconverged coming in, is that flash storage on the server is actually more economical and easier to use and faster. I mean, it's already fast, but if you can reduce a lot of the network latency connecting to external storage, you actually get to speed things up all the way around. And we basically feel that in the future, flash or reads are never going to leave the server. I/O is going to stay on the server. It's going to be protected somewhere else. And we heard some discussions earlier about we can't get away from backups and DR and things like that. But primary active data should never leave the server. This is kind of a premise that the founders got together and sort of built this architecture around. Also that as CPU horsepower has gotten more substantial, the more servers you put on this side of a storage array, the less that storage array can actually respond. You really have to scale that out as well. There's architectures for that, but they're fairly expensive. So what we see is essentially a cost aspect in the storage moving in favor of the servers, and a performance moving into more of a distributed, putting the workload closer to the applications. And that's essentially the foundation for this. So when I asked if anyone had seen or worked with hyperconverged, we think that there's a third evolution coming along here. All right. So if you sort of look at the application workload, where the virtual machine runs, where the application's running, where the data's where the compute's going. All right, that's obviously on the server. Traditional converged infrastructures, these sort of pod stack type solutions, all right, are very specific in these servers and this storage array work together. They'll vet out various solutions like VDI or databases, and it's very prescriptive, all right, in the organization, but you have to go over the network to get to the active data. All right, now it might be in hybrid flash, it might be in all flash, it might be very fast, but it's still over the network, and every host that you add has to go over the network to even read that data. All right, hyperconverged came along a few years ago. There's a lot of architectures built around it where they basically put the disks up in the servers, built out the nodes, a couple of disks, even tiered flash and spinning disk in the nodes, different architectures. But the data moved closer to the compute, but the way that the hyperconverged architectures are built is as you build out these nodes, and we heard a little earlier, the replication factor, the connectivity, those nodes are dependent on each other. So you're basically building a pool of storage down here of all of your persistent data across all of the nodes in a hyperconverged cluster. All right? We felt that there was a way to separate the active data and the persistent data, sort of take the best of both worlds of these first two, and essentially move the active data into the compute node, put the persistent data on the network in what looks very much like a storage array, but is really there just to give you that persistent copy of data across the nodes. All right, so this is what we call open converged. And the idea is that you can basically take any commodity server that's on the VMware compatibility list, put flash drives in it for local active data, and then connect it to the Datrium solution. And we'll run some software on the host that brings the storage layer closer to the application. All right, that's called open convergence. All right, so it's basically taking a hyper-converged style of architecture and moving it into more of a sort of an open platform perspective. This will be important when we talk a little bit later about how we're solving some fairly interesting problems. And what I want to spend a good bit of this next 30 minutes or so is talking about a particular problem that, that we tackle on a regular basis. And it's desktop virtualization. All right? I kind of look at that as the poster child, problem child of virtualization. All right? And let me explain that. When I take a server and I move a couple of applications onto it and virtualize them and have users connecting to that through client applications or whatever, whether it's a database or a message server or an application that I'm building, that server has, that virtual machine has certain characteristics that I can manage. When I start to go sort of an order of magnitude, let's say put 80 or 100 virtual machines on a single server and have end users directly connecting to those with their devices, all right? Not only does the performance considerations and the serviceability go up, but also the user experience is direct, all right? It's not like my email's a little bit slow. It's like I can't log into my desktop, all right? So it's a problem child in that sense, but it's also a poster child because if you figure out how to do virtualization of that level, you can pretty much back off and do any of the other solutions pretty well, all right? These are kind of questions that I get asked or I ask when I'm talking to people. I'm not going to read these to you, but they're kind of the, where do you get started with something like EDI or end user computing or desktop virtualization, whatever you want to call it these days. So the first thing I want to do is let's look at the problem, all right? Let's take just a brief step and say, what is it we're trying to solve? Kind of a traditional approach is, there's business aspects to it, there's architectural aspects, user aspects. You can't just go and say, I'm going to deploy Horizon and deploy 1,000 desktops and I hope my users are happy. You really need to understand the business reason for doing that and what your users are going to get when they switch from whatever it is that they're doing now. All right. Now, coming from the storage side, we can't solve everything. So we can't solve the network infrastructure, the access control, the security, the end user devices and all of that. But we can make sure that the infrastructure inside the data center that's supporting that desktop virtualization core is as optimal as it can be. And that's really what we want to talk about today. And what we find is that there's three common things that threaten that. So performance is one. All right. Flash storage in the data center has alleviated some of that, but I don't think it's completely solved it. Well, we'll have that at the end of this. I think actually we're getting very close to that. Complexity. all right? Because not only am I putting 80 to 100 virtual machines on a single host and speccing out all of the storage and moving pieces, there's a lot of things that have to go in, and you want to make administration of this easier, not harder, and obviously cost. I mentioned earlier that when Flash entered the data center, it came in through the storage market and typically had fairly high markups on flash arrays and flash cache and flash cards and all these things that optimize the storage. But what you find is you can actually go get like a 1 terabyte drive in your server. I don't want to say it's free, but it's relatively inexpensive these days. So putting a couple of terabytes across the host layer is much more economical. So what we're looking at is an architecture that's going to basically simplify things, bring up the performance, and reduce the cost. And I know that sounds kind of like magic. All right. Usually when I look at this with customers, and I've been working with Horizon and end user computing and a number of different platforms for a couple of years now. Great, thanks. We'll do this right after I'm done. Absolutely. Is I've got this, I call it the cloud or mobility test. Right? It's kind of like this test right here. So I've got this end user device. I want to connect to something. What is it I want to connect to? And typically, it's either an application or data somewhere that's not on this device or connected to this device. All right. And so the first thing you need to do is figure out where's the data, where's the application, how are things moving around. You can't just deploy a desktop and say, there, you're done. Hope that works. Because people don't use desktops just to log into them. They use them to get to things. What we're seeing a lot of is an evolution to, and this is the public cloud. All right, applications, Salesforce, CRM applications, Google. I mean, there's a lot of things in the public cloud, which is where we get our apps and our data. There's a lot of things, even right here, that I don't need my IT infrastructure to get to do things on a daily basis, mostly communications, but there are certain applications that I have to get from my company's organization. So there's certain things I might need to do on my device. I might need to work disconnected. All right, so when I'm not near a wireless or any kind of network connectivity, I might still need to get work done. So those things have to be figured out. And the key thing that I want to focus on today is what happens on-prem. Because I'm assuming most of you are responsible for your infrastructure, the administration, or the applications inside of, and I'll call them data centers, on-prem in your company's organization. Right? If you're purely worried about getting this done, we still got to figure out how to get from right to left. The thing here is, inside that on-premise environment is typically going to be some kind of access point that your users or the users for this desktop virtualization approach are going to want to get to. All right. Now they might be doing some of that work in that little yellow bubble, this bubble in the bubble here, but it's probably going to connect to other things either in the data center or in the cloud that you've created for part of your business overview. So trying to figure out what's going on here is the first step. All right, does that make sense to everybody? All right, the technology is cool, but if you're solving the wrong problem or you don't know exactly what pieces to put together, you can go buy the fastest hardware, the fastest storage, the latest, greatest stuff. But if you're not solving what the users need, it's not going to help you out. All right, so I kind of walked through this a little bit. At the end of the day, what we're looking at is that big chunk of iron in the middle there. All right, the servers and storage and VMware, vSphere, and we're going to talk today about Horizon as one example of doing desktop virtualization. And there's a lot of different ways that you can deploy that solution into an environment. So understanding the user needs, the business needs is going to be critical. Like I said, sort of analyzing the problem, but this is what we're going to focus on is what's going on in that centerpiece there. All right, so then the next step, let's just assume that you've gone and you've talked to your users, you've done your budget analysis, you've figured out what parts need to be connected, what needs to be supported. You want to design something, all right? I don't know what size your organizations are, but typically desktop virtualization or virtual machine environments, and I'll say under 100 instances. I don't want to trivialize it, but the horsepower and technology out there is pretty straightforward, and it's almost impossible to go wrong buying some good stuff, all right? A couple of 3, 4 servers, you can spread a lot of workload out, but as you start to scale, if you're supporting a campus or a hospital or a large office complex or worldwide organization, or something that has hundreds of users and hundreds of instances, you're going to want to be able to make sure that that scales, and you're probably not going to be able to do that all in one sweep. So you're going to want some kind of modular or phase development, all right, understanding what the requirements are going to be. We're going to dig into VMware a little bit on this, and then looking at how you might size this out, all right? And when we come back to that, I'm going to go back to some of the things that Datrium brings as a solution that I think will make this an interesting sort of exercise or problem, all right? Again, today we're going to focus desktop applications. They typically tend to be Windows 7, 8, or 10. We are seeing some Linux deployments as well, where they're deploying out literally hundreds of Linux nodes for users to log into, partly because of the applications or what they're trying to do. The broker that we're going to focus on today, and the broker to me is the component that helps build and manage the connectivity to those hundreds of instances. Like I said, if you're building out smaller sets of servers for virtualization, Exchange, SQL, things like that, you can pretty much handcraft those, or with a manual clone operation or two, you can spin up a few more. But if you have to manage literally 200 or 300 or 400 instances on a daily basis and make sure that they're running and that they're running the right components, you're going to want something to help not only compose or construct those, but also manage the user connectivity to them. All right. And then the last little layer here is essentially vSphere with vCenter, all right, where the virtual machines live, and then at the bottom is the physical layer, the network, compute, and the storage, and that's the piece that we're going to talk about a little bit today, because I think the Datrium solution for server virtualization, and in particular desktop server virtualization, is fairly interesting. All right. How many people here have had a chance to work with Horizon View, or Horizon, or desktop virtualization? Okay, handful, a couple people. Not majority. So I want to take just a moment here. So desktop types come in a lot of different flavors too. All right. This desktop right here, I would call this a full desktop. When I close the lid, everything stays inside of it. When I open it up, everything is inside of it. I can work remote. I can work wherever I want. I can connect to the network. I really, most of the work on this right now is not tied to my on-prem environment. All right. I did have to run out for a minute to Starbucks and get on wireless and take care of something in our lab that we're working on development, but for the most part, this is a full desktop. It's all installed there. The applications that I need are mostly loaded here. There's a couple of applications that I do have to connect back in to headquarters to get to. There's another version called a linked clone, all right, which is essentially a partial, as its name is, it's a partial desktop. It's built off of a master image, all right, and basically allows me to spawn a bunch of instances from that. The interesting thing there is a full desktop, once it's deployed, is basically self-managed. All right? If I want to apply patches to this, I apply patches to this. I don't reinstall the OS. I don't re-roll this entire thing. With a linked clone, I can basically create an instance and then use a feature called Recompose, where I can push patches into the master image and then roll that out. It's a lighter footprint, it's a little bit more dynamic, it's a process consideration for managing different types of applications in your environment. Not only that, between the two types of desktops, I can have persistent desktops, which means when they turn off, they go off, the data's on them, they stay that way when they turn them back on, all right? They're sort of wholly contained. Dedicated laptops, or dedicated desktops, are assigned to end users. So when they log in on Monday, there's the picture of their kids on their desktop. When they log in on Tuesday, the picture's still there. All right. And then there's floating. Think of this more like a kiosk or a library. You log into the desktop, you do some work, you log out. The desktop typically gets flushed or thrown away. You log back in. It's a nice clean desktop. There's not somebody else's stuff laying on it. You don't see other people's kids' pictures on the desktop. All right, it's a true floating kind of, almost like a hoteling concept in an access point in the data center to get to something else. All right. Storage considerations get to be interesting at this point. All right, if we sweep all the physical desktops out of an organization, take them out of all the labs, all the classrooms, all the offices, off of all the nurses and doctors' desks, all that data has to go somewhere, and the data is typically application or user data. And a small part of that is infrastructure data, the desktop itself, the applications themselves. All right, we've got to figure all of that out. Before you sort of sweep through this, user data or file management is also another aspect. in a lot of organizations, you may have already started a migration to have user home directories. Users put their data in a central place, then it gets backed up, protected, so that IT, if they have to replace the asset, isn't as burdened by doing a 300 gig backup before I can do a restore to a point in time. All right, so keeping track of all of that, I think what you're going to find is we can put all of that in a common storage platform to solve this from performance, cost, and simplicity, the three things that typically cause problems. All right, a little hard to read, but I'm just kind of, when you're using Horizon and you're constructing one of these environments, so this is why going back to understanding what your users need and what you need to put in that instance in the data center is important, is I can basically pick, in this case, automated, floating, or dedicated desktop provisioning. So my broker is going to give me mechanisms for spinning out literally sets of these, from 1 to thousands if needed. All right? And I need to make these choices as I'm sort of specifying how I'm going to solve the problem for my particular infrastructure. Not only that, is full desktops, like I said, are full instances. They're built from golden image templates. You make a template VM, and you spin a clone off of that. Once you spin a clone off of that, it's detached and moves on. All right. If you want to redeploy it, you go update a golden image, create a brand new full desktop. All right. It has implications on provisioning, on management, on storage, on performance, a number of issues. Linked clones, a little bit different. They're actually built off of a snapshot point on a live VM. It might not be turned on, but it's a full VM that has a snapshot. And using VMware's snapshot capabilities, we basically can create a new snapshot point and roll an instance out underneath of the desktops that we deploy, a recomposition operation. All right? And the way that's done is it essentially moves a new instance of the OS and applications out into the desktop image, doing some delta change and some re-imaging of each of the instances. It's done in a maintenance window, so it's not completely non-disruptive, but it is fairly straightforward and streamlined. So if you want to roll a patch into the golden image, take a new snapshot, recompose, do that once a week, you're going to be basically tweaking potentially hundreds of VMs on a regular cycle. Well, what about user data? Or the stuff that lives in, if you're familiar with Windows, in sort of users my name folder. All right, anything that I download, create, or work on typically gets trapped inside the desktop somewhere. Unless I'm explicitly sharing it out on another place, that data might be in that desktop. All right. So with linked clones, I have the ability to specify persistent disks for user data and even disposable disks for temporary data. So if I want to do a refresh and kind of throw away, it's kind of like clearing your browser cache. All right. You can basically move data in and out of these desktops. Now, all of this stuff that's going on, think about the impact on the underlying storage layer, right? Where the bits are moving and where they're coming from. All right. In previous architectures that I've worked on, and like I said, when Flash came into the market, it was like, well, put your OS disks on Flash, put your user data out here, you put it on different tiers of storage, you can come up with a very complex approach to partitioning that out. But I want to sidestep for a minute and talk a little bit about the Datrium solution and what we've done. I introduced it very briefly at the beginning, but I want to spend a moment now talking about the architecture of it and how it works and how I believe it's going to help solve this particular sort of virtualization or storage complexity problem. So the DVX, that's the name of our product, essentially runs on your host servers, on your ESX hosts. All right, so essentially any host that you have in your environment that is on the HCL, kind of, we'll start there, has Flash in it that's also compatible with that host, compatible with the server manufacturer, compatible with your support programs. So if you've got dev hosts, you can put commodity Flash in it. Even if you've got to go out to your server vendor and buy that terabyte or two of Flash for the host, it's going to be almost an order of magnitude cheaper per terabyte than if you were to go to your storage manufacturer and ask for that Flash. All right. The data server here at the bottom is actually what we sell. All right. I put a little icon up here. I can show you a picture of it later, but it's essentially a 2U appliance. Looks very much like a storage array. It's got disks in it. It's got controllers in it. It's fully redundant, so it's got active, passive controllers, multiple network links, multiple power supplies. It runs with a RAID protection on it, which I'll talk about in a little bit, but it's essentially your persistent data on the network, but it also is the connection point for your virtual center. All right? So your virtual center connects to our data server, and we can then push this DVX software into each host. We call it a hyperdriver. It essentially rides in at the data store level. It presents the data store as the combination of the local flash that I put in here and the persistent storage out there. So we've separated performance from capacity across your network. All right. So while that system is running, writes are going into the local storage, and they're also going out to the persistent storage. All right. Now they're doing that not necessarily at application write characteristics. All right. So because we've got the DVX software running in the host, we can do some things like RAID protect the storage, dedupe, compress, manage it, and so what we're writing to the local flash on the host for later use, and we're writing out to the data server for persistent sort of longevity of data. We're doing that in very optimized ways. So if you imagine an application's doing the VM blender, a lot of I/O going on. The I/O is coming into the host. The DVX software is managing that, coalescing it, compressing it, deduping it, protecting it, and writing it down to the flash layer and the persistent storage layer. All right. All reads then, if we have enough capacity on the host, come right off the host. They never go back out to the network. So the only thing that goes out to the DVX data server is essentially your persistent data. And you want that because you might want to keep the system from crashing, or if it crashes, you want to recover it quickly, or you might want to move things within the environment. So the separation of the components here and the way we present the storage solution makes it fairly easy. So in something like a Horizon environment or any virtualized environment, all I really need to do is point to, whether it's full or linked clones, point all of my storage artifacts to the Datrium DVX data store. Does that make sense? Mm-hmm. All right, so we're presenting a single data store that each host can see. It's a shared resource. We're using the NFS mechanism so that every ESX host can see the same data store. The data store has the current active data on each host that host needs, yet a persistent copy of data out on the network that each host can share, all right, without worrying about the hosts themselves managing that persistent data, all right? So from a simplicity perspective, almost anything I do in the VMware environment, I can basically park it on the single data store, and it'll stay resident in the local host flash and persistent out on this network resource, which is shared between the hosts. All right. So then, interesting, but it's not free. Right? There is a cost to this, and I want to talk about that now. So when we're looking at virtualization, the desktop virtualization, a core count of the host is going to be fairly interesting exercise now. We've shifted a slightly different consideration. All right. When you bought storage before, you typically looked at the storage array, you looked at the performance capability of that, and if it was enough, then you deployed or you upgraded or you get to or whatever. All right. We've shifted the storage performance now onto the hosts. And what we're going to do is take a small amount of the host resident CPU to run the storage I/O. The DVX software that's running on the host is taking host resources. All right. So those virtual machines that I have to run there, and my ESX that that has to run on the host, that runs the host, and my Datrium software now all have to be accounted for. All right. By default, we take up to 20% of the local CPU on the host. Now, we think that's actually pretty fair because VMware's sort of study of their community shows that ESX hosts are typically loaded about 40%, that there's a fair amount of headroom. In VDI situations, it's going to be a little bit more intense, but not terribly more. So taking a little bit of CPU core count there actually can give you a huge benefit in performance and scalability. All right. So we're going to want a little bit of a design reserve there as we build this out. The memory footprint. So as I'm looking at hosts now, we license by socket. All right. No, we don't. I mean, VMware licenses by socket. We don't license it to host at all. Host software just gets pushed up. You basically buy our data server, and we push the software out to the host, no cost. So it's unlimited number of host connections. We really don't care what they have as long as they have enough horsepower to make you happy. All right. And so if you look at core counts now, typical Intel V3 and V4 systems are running, on the order of 2x6 to 2x18 and more. All right. So 12 to over 36 core on these hosts. All right. So what we're saying is we're going to take a couple of those and run your storage idle on them. As you look at the design of your virtual machines for your users, you're going to want to figure out how many core they need to run their workloads. And there's a lot of resources you can look at. Rough rule of thumb I use is about 4 for oversubscription. So if I've got 4 users, I need at least 1 core. 4 desktops, 1 core kind of thing. All right, and that's going to let me play around a little bit with sizing. As I build more intense desktop profiles, I might reduce that a little bit, or I need more core. All right, and then I'm going to want to match the memory. All right. Disk space characteristics here. The thing we want to keep in mind now is we're looking at putting storage on the hosts as well. So in a hyper-converged infrastructure, you're going to basically buy a node. It's going to have a prescribed configuration and footprint. It's going to be one of maybe 10,000 items on a SKU, some combination of memory core, local disk, and persistent disk. And you'll basically build that or select that relative to what you're doing here. What we want to give you here is a little bit more flexibility. So each host now has local flash on it. Anywhere from 2 to 10 devices, anywhere from 800 gig to 16 terabytes is what we support. But that essentially lets me put on that host enough flash to hold the workload of the desktops or the virtual machines that I want to put on that host. So if I'm putting, let's say I'm going to put 80 or 100 desktops with, at worst, a 30 gig footprint. All right, I need about 2 terabytes raw. But we have deduplication and compression, so easily 1 to 2 terabytes on that host are going to be sufficient of flash in the host, and that'll basically get backed by the DVX data server. All right. A couple of other things in the exercise, just sort of looking at distribution and how you play this out. What we want to make sure is as you look at deploying and scaling and modularizing the environment, that you don't run into a performance problem or a barrier in the deployment choices that you have. And we'll see that in just a minute. Okay. So let's look at a quick example. All right, I'm taking 80 desktops per host, kind of a rough number. This is a 20-core host. This is a circa 2-3 years ago E5 26 something, but it has 2 by 10. All right, a V3 architecture, a nice little workhorse. All right, we put 256 gig of memory in there. What can I deploy on that now? So if I take those 80 desktops, I'm still at my rough 4 to 1 oversubscription on CPU. If I put 2 to 3 gig of memory in each one, and it might seem a little low, but I'm going to look at the particular instance I need to support, but that should fit in there. And then I could basically scale this out roughly from 4 to 12 nodes and go anywhere from 300 to 1,000 of these instances in my environment. So if I were deploying a campus, student access to a lab or to some material, or maybe nurses in a hospital, doctors, you can look at that. This might be one way of looking at it. The device that we have has 30 terabytes of storage on it. So that 2U appliance has 29.4 actually terabytes of storage on it. That's pre-reduction. So I'm going to have plenty of capacity to hold all of that. And this is just kind of one example. It gets more interesting if you want to scale this out. All right. Now your environments might not be this big, but we do run into some that are literally 400, 500, 1,000 instances of users or desktops in a company. My company right now, we're a couple of hundred engineers and employees, but each engineer, each person in our company has 2 or 3 instances back in the data center that are doing different things. They use them to do development on, they've got Linux desktops, they've got Windows desktops, access points into our intranet, things like that. So the count might not be just tied to users. The idea with this slide here is that we're giving you flexibility now to build out the sort of north side of this problem. This end of the problem, is up to you. Now you can pick servers. So this idea of open converge, so I can pick pretty much any server that I want, put any kind of flash that's supported in that, and introduce it to the Datrium solution, and turn it into essentially server-powered storage off of the data server here. So if I wanted to begin clustering little groups of servers in here, I can now have the flexibility of dealing with specific user problems. So go back to that orange, blue, yellow bubble problem. It's like when I start to look at what I'm trying to access, I can now start to partition out what I'm going to deliver in my organization. Now you might not put 8 blades, you might put a couple. Your size may vary, but the flexibility is the real key here. Is we're not specific to performance of this entity alone. We're actually tied more to the performance of the hosts. Okay? Does that make sense? All right. Next 2 slides kind of spell out sort of the magic behind this. As I bring hosts to the solution, I bring their CPU. I bring their local flash drive, their local flash resources, and I'm essentially extending the performance of my system. All right. So with a typical all-flash array controller, for example, I buy something, it has a spec of what it can deliver. Just because I add more hosts, the array doesn't get faster. All right. Hyperconverged kind of solved this. It said as I add more nodes, I'm bringing more compute and storage to the problem or to the solution. But I am creating a slightly different problem. Is that all of those hosts now have to manage a little bit of each other's storage. There's east-west traffic going along, so the separation isn't nearly as linear here. With the Datrium solution, as I add a host, I'm bringing new resources to bear. Now the blue, green, and black lines here kind of show the horsepower aspect. If I bring more cores or faster cores, I bring more horsepower. All right, so these become design decisions that you now have the flexibility to go look at as you're looking at storage performance. You used to look at that purely from compute performance, but now you can take the core count and the core speed as an aspect of the storage performance. The other thing we've done here is we've sort of enveloped it. We have this feature called insane mode. It was a real, and actually the hats we might still get, logo to that, but the out of the box is fast, all right, up to 20% of the available CPU. Now we won't step on the processing, we'll basically take the excess CPU, all right? But we won't take more than 20%. If you switch into insane mode, and you can see in the upper right-hand corner, it's literally the click of a button on the UI, we'll then say, we'll take up to 40% of the available CPU. You might say, why don't you just run in insane mode all the time? Well, you might have considerations of resources, and I don't want to say QoS, but you might want to basically say 20% of that host is sufficient for the workload that I need, unless you're running a benchmark. If you're running a benchmark, you always pour the nitrous in and you go. All right. But if you're running a normal workload, fast is typically, or will be sufficient. And what we see here is based on the core count of an individual server, kind of a ramp. The more cores that server has, the more storage I/O that server can do. And whether it's fast or insane, or we blocked out 4 and 32K, which kind of bookends a good bit, about 95% of the I/O that we see in most workloads. You can see the roughly, this is about 17,000-ish here, 15 to 17,000, to well over 100,000, depending on what we're doing. So, and like I said, it depends. I can't give you a hard number. I can say your server and the I/O that it's doing is going to fall somewhere in this envelope, depending on how you're running it. And that is going to be fairly sufficient for running desktop virtualizations. All right, and that's what we found is each host now basically runs independently of the other hosts. Now, if I've got virtual machines or desktops that are on the wrong location, all right, some QoS take this sort of what I call restraining order approach. It's like go find the culprit virtual machine and limit the resources it can have. All right, shut it down. All right, constrain it. In a lot of cases, that's one way of doing it. The other way is look at the environment and say, I've got resources over here. Why don't I move you to a better neighborhood? All right. So with vMotion, I basically can take virtual machines, and I can do this with DRS. I can do this with rebalancing, a number of things within VMware. But I'll basically move the resources now. So storage now becomes almost as equitable resource as memory and CPU were before. All right, and because I've got the shared data server, I can simply move over, recache a little bit of data, pull it from the previous host if I need to, but I can still run at speed on a new host. This is about the only time we'll actually seek east-west traffic between the hosts. All right, does that make sense? A couple more things here I wanted to talk about. So testing. All right, I could get up here all day and talk about the benchmarks we run and what we do. I've been doing this for a couple of years now at Datrium and at least one other organization, and closely with VMware and a few others in the desktop industry. And testing these environments out is critical. We do this in our lab. We do this with our customers. It's important to understand that the choices that you're making are going to work out. All right? And there's ways of doing this without huge frameworks and harnesses, and there's ways that you can get others involved. That video that we showed that was running at the beginning, I'm going to come back to in just a second. Things like boot storms and startup and login storms, pretty easy to do without too much work. I can create 100 or 200 virtual machines and literally red box, green triangle them all day. Just turn them off and on and see what happens. And look at the impact on the hosts, on the network, on the storage, on the artifacts in the environment. Sometimes I can even get a user login session. I can set a user to log in automatically. And that's, when the thing starts up. That gives me at least one more perspective. I want to kind of share a little note that we found here. A typical Windows 7 desktop, all right, and this is not a virtual desktop, this is just a desktop, a Windows 7 image running your basic Microsoft applications. From the moment it's powered on, from cold red box to running green triangle, all right, anyone want to take a guess at how much disk I/O that does? Well, we've done some testing both here and at other companies and independently. There's about 30,000 disk I/O operations. Not 30,000 IOPS, but 30,000 operations to go from dead cold to the next thing that the user wants to do is unimpeded. All right. Now, you might be able to log in at 10 or 20,000, but there's still stuff running and little arrows going around. It's not there yet. So boot storms are pretty, I won't say catastrophic, but they're pretty intense. 100 desktops starting from cold, let's say rebooting an ESX host, or migrating them, or restarting them, or a classroom. 100 students come in, they want to get started, they want to basically boot up, log in, whatever. Logins are about an order of magnitude less. A user login takes about 3,000 disk I/O. Still pretty intense, but you're going to want to make sure that those things happen quickly. All right. And they create a huge pressure on the storage layer. If the storage is wrong, it's just going to fall over. All right. We'll do a little math here in a minute. I mentioned all the desktop types. Full, linked clone, persistent. All right. Those things have provisioning impacts. If I want to build 100 full desktops, I basically have to take a template and do 100 clone operations off of that. All right. Now, we all know how long it takes to do storage cloning. The storage layer, if it supports VI technology, can do storage offload, make that a lot faster. All right. So you want to look for things like that. If it's being deduped or compressed, it'll take less space on your eventual target. That's one aspect. And you can test these out. Linked clones still have to produce the golden image and then do all of this provisioning. Still have all of the things that have to hook up the applications and connection to Microsoft, whatever. So testing this out, these can all be done sort of within the Horizon environment, for example, without ever getting a user involved. You can spin up a lot of instances and just kind of see how they work to make sure that they at least pass test before handing anything off to the user. One thing I would also suggest before actually getting your users in front of these desktops, unless you've got really, really friendly users, is to do some kind of user workload test or find somebody who has done user workload tests against the particular solution that you have. I know we do this at Datrium now, and we use a tool called Login DSI. Anybody familiar with that? Okay, you may have heard of it. I would suggest going out and checking out their website if you're looking at desktop virtualization at all. They have a lot of interesting white papers, techniques. They've got a download that you can play with, and they've got some good resources. Make sure that whoever you're working with is familiar with this, because this is the tool that VMware, the primary tool that VMware is using now to certify all of their desktop virtualization solutions. What it allows me to do is create workload profiles. All right, so that thing we saw running at the very beginning was a knowledge worker profile running on a couple of hundred desktops, just as a little example. So we basically started up a workload, and it was running. And what you could see is it was actually automating. It was a little, interesting. Users logging in and sending email and creating documents and watching cat videos. Anybody catch that one? There's a cat video in there.
Yep.
All right. But I can literally spell this out. So I can do things like this. I can say, I want to take 150 desktops. I want to log in within 1 minute. Kind of hard to see, but 150 desktops, 60-second login. And I want to do knowledge worker and run for 3,000 seconds, or about 50 minutes. This is emulating a classroom experience. All right. I want to see what that does. I want to see how that looks. How does that work on my system? How many hosts do I need to make this run appropriately? All right. And I might then see something like this in my vCenter. So can I do those 150 equitably on 2 hosts? Well, the 2 hosts that I have, how many people are comfortable running at 80% utilization? That's sort of where you'd like to get to, but you don't want to get into the red. You don't want this to turn into a Christmas tree, light up. All right, but you do want to get what you paid for. And maybe you have another host on the side for spare, or you spread this out a little bit more. But what you're going to do is look at the resources and how hard they're used. And then the interesting thing about Login DSI is not only does it automate the workload and emulate these users doing all this work, but it's also tracking their experience. All right, it's literally a fairly sophisticated tool that's indexing all of these users. So those 150 users that logged in, as they were opening up Word or writing emails or looking at things on the network, it was tracking their access time. All right, and this is more, although it says milliseconds, think of these as more sort of at the second level, human time. All right, and this blue line basically tracks out where your resources and response time are going, and you want it. The VSI max is sort of like how happy your users are going to be. All right, you can see that little X out there at the end. We didn't quite get it. All right, we were a little bit in the yellow. We were pushing some things. This might be still sufficient, but from just a general observation, this tool says you've pushed the limits. I got to 148, and I started to get a little resistance from the operations. Now, it might not be storage. It might be compute bound. It might be memory bound. All right, it's not going to point to what is the problem, but it's going to give you the tool and the mechanism to understand what's going on. So we go back and say, well, maybe I'm compute bound here. Okay, maybe I need more horsepower. Maybe I need to switch down to a fast mode as opposed to insane. Or maybe I need to get more flash drives. We've got to look at the environment to see what caused that. And this is what we do as vendors that sort of vet out our scenarios. We look at numbers of users, scenarios, workloads. Boot storms are fun. It's kind of fun to go and literally like fire up a couple hundred virtual machines and just watch them sort of crest and what happens to the infrastructure. I'm going to show you that in just a minute. Okay. So just to kind of wrap up, I want to make sure we stay on time here. A few things about the Datrium solution. So we put the DVX software on each virtual machine. We talked about desktop virtualization as a problem space / problem child for that. But by separating the performance of the capacity and isolating the performance on each host, I think we have a very strong solution for scalability and simplicity of management. All right, so we've essentially separated the performance domains from the failure domains. It gives us resiliency and flexibility. This idea of the platform for open convergence. In VM clouds, it could be desktops, it could be applications, it could be databases, virtual machines. All right. We've taken a VM-centric approach to this. The single data store presents itself very easily. All right, we plug right into the virtual center environment. All right, we provide stats at the vCenter level, the host level, and the VM level. So you can now look at storage in much more detail within your vCenter environment And the optimized data layout is basically here for HA and efficiency. All right, so the data reduction and the way that we've laid things out on Flash and on the data server make it very efficient to maintain and to move around. All right, and so the basic benefits that we think for VDI, like I said, simpler storage management, all right, performance isolation, all right, local reads from Flash, all right. You're not going to beat not going over the network. Now it might just be milliseconds, but those add up over hundreds of desktops, over hundreds of virtual machines, over hours of the day. All right, and so what we're looking at is a better latency response time for almost all of the reads. The writes are basically running at write speeds that you really, there's a limitation to how fast you can write just about anywhere, whether it's Flash or over the network or local storage. All right, and we think with the open convergence you get a much better, more cost-effective, flexible platform to build from. All right, and with that, I wanted to fire up one last demo here. And I said boot storms are always kind of fun. Let me get this one out of the way. This was the desktops at play. This is basically what's happening inside of one of those login DSI automated sessions. So it's actually running, starting things up. You'll see every so often you'll see like little things, getting a cup of coffee, workload starting, taking a break, calling a colleague. It's trying to emulate as close to a workload, or at least a measurable workload that you can use.
So you were saying that that's an application that people use to do a test of their VDI environment?
Yes, so Login DSI is a testing framework, and you can basically, they have a demo version of it for like 50 users. You can buy a per user kind of license. It varies. It's usually used by vendors and consultants and people and resellers that are going to help you deploy, because it helps them understand your environment, mimic it. You can use it very nicely inside your environment also to plan out changes. So let's say you're doing a Windows 7 to Windows 10 upgrade. How many people have done that already? A few, but not all. You might then build out your Windows 10 desktops, run them on the infrastructure, load the applications into it. It's a fairly expensive platform. Like I said, I would suggest going looking at their website. I've been working with them for years. It's a very robust product, and from a sort of automating the testing of it, it's essential. I mean, you can do certain things without it, but you really need to get in and make those. It's kind of like running benchmark tests on a database. You want to run against the database. You want to run some production workloads of some sort, so you can see what the parts look like when they're moving. All right. And this example here, I want to just kind of go through is basically record this. So here we're in Horizon View. We've got 200 desktops. I typically work in a couple of hundred, a few servers, just to kind of make sure the parts are working. And then we'll deploy hundreds or thousands to get limits tests. But we can see here that we basically have dedicated linked clones, which means these are going to have users assigned to them and user data on those linked clones. And we can see here in Horizon View that they're all set up already. So I've already provisioned them. I've already logged in the users, which means they've already done their profile create, and a lot of the background, the tasks of setting this up. So they're all in DNS, they're all prepped. So these are basically all ready to go, hand out to my users, all right? This was like prepping for that other demo that I was just showing you there, all right? And what I do is, I'm going to start with a quiet environment. Basically, I'm going to shut them all down. This is the, let me back that up just a minute. This is the Datrium UI. With no storage activity. So inside your virtual center, you can see IOPS throughput, DAVG latency, which is latency at the virtual machine level. So we're not looking at component level. We're actually telling you how the I/O is happening at each virtual machine in this environment, and whether we're getting cache hit. So do we have enough local flash on all the hosts? All right, fairly quiet environment here. So let's kind of go ahead and run through. I'm going to basically just select all the desktops and kick them off. All right, select them all and then green triangle them. And this will just take a minute or two. But the thing I want you to see is the impact on the storage and what we can go see and sort of what boundaries we might be looking at. So basically all light up here, power them all at once. We can look around. Now this is in Horizon. If you look in our vCenter, we'll then see that these desktops or these virtual machines are all powering on. All right. Every one of them is doing about 30,000 disk operations right now. All right, so 200 times 30,000. Quick math. Is that about 6 million?
Yeah.
600,000?
200.
I always have to get a whiteboard to do this.
A lot.
30,000 times 2
30,000.
times 200, 60, 600, 6 million IOPS.
Yeah.
So what we can see here is the response time now ramping. All right. So I've got 4 hosts. Each host is bringing a certain amount of capability to the solution. We can see we're clearly cresting close to 100,000 IOPS per second off of those 4 hosts. All right. So somewhere in that bandwidth that I showed you earlier, I'm doing I/O. Most of it is read activity. I'm trying to get these desktops up and running. All right. And I'm just going to kind of look around to make sure that the tasks are completed. Remember, I told you before they're completely done, I mean, they're powered up. So vCenter says power's on. I've gotten the VM tools agents basically have said hello. All right. I've gone to my Horizon environment and it says all of my desktops have checked in with the connection broker. So you can basically start logging into them so then they're all available. All right. And then I can go back to the dashboard a minute and kind of look at what happened. All right. And this is kind of the interesting part here. Let's see if I can stop this for a minute. So we're going to look at this little spike here. All right. And if we look right here at the peak, 111,000 IOPS were recorded across the 4 hosts. So that's like 25 to 27,000 I/O per host coming in to do this. A typical storage array is going to be hard to hit those levels without spending a huge amount of money. In a hyperconverged environment, we might be able to get that from local flash, but we've got the manageability of the hyperconverged cluster and the pools and all of that to worry about. But essentially, notice here, sub-millisecond latency has been a little spike in here of some write activity. It's probably dumping out the temp file before getting started. And then the point I make here is that the more hosts I bring, the faster this goes. All right, so if I had 3 hosts that would have run at one particular speed, I could add more hosts, I could spread things out. I can mix this in with my environment. All right.
So I'm just trying to understand how the system works. So you're installing like an agent on the host or an agent on the VMs?
So good question. We install software on the ESX host.
Okay.
We call it a hyperdriver. It's the DVX software. It runs as a VIB, an installation tool, so it runs sort of between user space and kernel space. So it's not a virtual machine that has to be managed. It is essentially think of it as a file system driver that is presenting the DVX NFS data store. All right, and what it's doing is taking the local flash resources and essentially caching the persistent data that's on the network. All right?
So that one I think it was a 1U device that you were talking about. Is that the flash storage that that is pointing to the host, or are you talking about you're throwing in you're throwing flash on the host themselves?
We require flash on the host. Yeah. So 1 to 10 flash devices, at least 800 gig of flash on the host. So it is actually in your ESX host. It shows up as a solid state drive, a PCIe card, whatever shows up to the hypervisor. If I go to manage storage, I want to see a flash device.
Okay, so you're putting hard drives in basically in a host. It's using the backplane of the host to talk, but because you're spreading the load of the drives, you're using NFS.
Because we want the data server to be accessible to all of the hosts, and we don't want to have to worry about a lot of storage management tasks, we're presenting that as NFS. That's one of the simpler sort of storage platforms. If it was VMFS, we'd have volume sizes and all sorts of things that had to be laid down on there. It gives us a certain amount of flexibility also to treat the storage at the VM level. So each VM is an artifact we know about. So as the virtual machine sits on the Datrium data store, we can track that. So as we start to look at things like cloning and snapshots and other future capabilities, we'll be looking at that at the virtual machine level and not necessarily at the data store level or at the volume or line or pool.
NFS protocol, what version are you guys supporting? 3 or 4.1?
Pardon
NFS protocol, what version is
Right now it's 3. Yeah.
And these hard drives are they like a PCI card or is it an actual hard drive in the slot of the manufacturer?
It is up to you. So part of the Open Converge platform is you take your hardware and put flash in it. All right. So in my lab, for example, I've got some Cisco blades with some drives stuck in the front. I've got one with a Fusion IO card on the PCIe. I've got a white box server with a mix of stuff in there that we test. You typically get it compatible with your server and compatible with VMware. Question?
What's the hardware like on your actual device?
So the 2U device, we call it the net shell for the data server, has 12 disks on it. They're spinning 7,200 RPM drives. So they're very cost effective and they're 4 terabytes, so high capacity. The RAID is actually done at the host level. So we treat the data server essentially as a set of independent disks. It's a very interesting technology. We've got a white paper on the website if you really want to dig into the architecture of it. But the device itself is 2U, 12 spinning disks, dual controllers, dual power supplies, dual networks, 10 gig network to the data layer. All right, redundant 10 gig network. So it's highly available.
Why wouldn't you use flash on your data store?
Good question. So and we're looking at that.
Is that just a cost thing, or?
It's a cost and capacity, and we're chasing that right now. So when we put this thing together a year or two ago, all right, flash drives were just getting interestingly large. So to put 12 flash drives into the data server, a year or two ago, we would have had about a fourth of the capacity at almost twice the price.
Okay.
All right? And what we're relying on there isn't the speed of that disk. All right. In some rare cases, having flash out on the data server might be interesting from a power or economics perspective, but for the most part, that we found, until the price points move a little bit, having flash on that really doesn't help. The way that we lay the data out there and the way it's treated from each host, spinning disk is fine. The interesting thing to note, and I like I say, get into the details here, is because we're not doing individual I/O to either the local flash or the disk. Right, the local I/O is basically being done in memory on the host. That we can essentially gather up those I/Os that go out. We are doing one place we do direct I/O, and that is to the acknowledgement layer in NVRAM on the network. So part of what happens is when your application does a write, we want to make sure that is ultimately safe. So it goes to NVRAM on the persistent data, and it goes into flash on the local host. All right, and basically that's at block size, and this is done at sort of what I'll call managed size. So we're taking advantage of a lot of sort of intellectual property on the host to make that happen.
Is the flash pooled across the hosts, or is just dedicated to each individual host?
Flash right now is dedicated to each host.
Okay,
All right,
so
that
there's
way-
no pooling.
There is
Like if one is starved and the other one's is overloaded, there's no
right.
balancing of that.
So, correct. And two things happen. One, with vMotion or a vMotion activity, you could move a host that's starving and spread the workload out. I've got a little demo where I take 3 hosts and I shove 4 applications on one host. And I'm basically pushing that host. By spreading that out, I literally almost quadruple the performance of the applications themselves because I'm moving resources into more fertile ground. By not having a dependency on the other host's flash as a resource, we reduce east-west traffic noise. So the hosts don't really need to know about the other hosts in the environment. It makes sort of failure mode, simplicity, the high availability a lot cleaner than if we did have to worry about other hosts' resources. And that was part of the architecture. It was really to separate the hosts and then separate the performance from the capacity aspect.
Is there a ratio for how much space you need? So if you have, say, 2 hosts, and you have, say, 200 VMs running on these 2 hosts, how much disk space, how much flash disk space do you need to accommodate these boot ups, these boot storms?
So good question. So you'll want to do some sizing. So going back to like provisioning, or just build out a couple of the virtual machines and see how much they take. Because we've got thin provisioning and we've got data reduction happening as well. And so that question's somewhat qualified. But our answer is that the host should have abundant flash. All right. So if you think about, like, back to that example, let's put 100 virtual machines on a host, and each one needs, a couple of gig just to hold its active data, its desktop, whatever it's doing. Then I might need, a couple of 100 gig or a terabyte or two. Our recommendations right now, you start with 800 gig minimum. That's required. So that host has at least 800 gig of flash with maybe 2, 3, even up to 6x reduction on it as the capacity. So as I put more and more like instances on that host, I need less and less total storage. So we think that we found a nice interesting point where the flash cost and availability at the host level is very economical. So imagine this, the data server has about, we'll say 30 terabytes of available space pre-compression, pre-reduction. If I were to take a dozen hosts and put 2 1 terabyte drives on them, all right, I'd have 24 terabytes of flash backing my 30 terabytes of persistent data, all right? And we know that we don't access all of our persistent data all the time every day. So the ratio there is actually really good. Now, if I have an application, let's say I'm running a database somewhere, it maybe has a large data set. It might have a 500 gig just on its own. I could literally put flash on that host and hold that entire data set in that host, and it's persistent data on the net shelf. So, like I said, it's sort of bringing the best of the hyper-converged, move the storage closer to the app, and the SAN array of keeping a shared resource minimally connected now.
Will it always favor flash? I mean, even if it's cold data that could probably go down to spinning disk, but there's flash sitting there available.
So the writes always go to the data server, persistent data, and to the local flash. Reads will always attempt to come from local flash first. So there isn't this notion of tiering, or as data gets cold, it gets moved off. Flash on the local host will basically get used to the level that it needs. So if the data goes cold and more hot data comes in from somewhere else, this is where you can start to look at the sizing aspect. We give you measures of sort of headroom. So if you wanted to say, well, let's just put a terabyte on there now to get started and see how well that works, you'll see how much cold data evolves from that environment, because you'll see how much the host is using versus how much it's actually storing. Right? So there's no tiering, and it's fairly dynamic and flexible, but it always prefers the local flash. Cool. All right. Mike, you want to pull one out of here?
Sure.
I see a lot of my cards in here, so I'm not going to even, which is cool. Let's get to the. All right, so that's only one. All right.
You
There
win.
might be a few blank ones in there. I'd like to throw a stack in just to see. That's why I said
Pick a card,
There we
any
go.
card.
All right. Pick one that's not black and white. Yeah. All right. And my glasses here. Hugh Gamble.
What's on the back? No, because I put it on your name, so it's yours.
All right. The Apple Watch.
I have to buy an iPhone. $800 later.
Oh yeah, the iPhone 7. Yeah, it's here. Any other questions? Like I said, my card was in there if you want to connect. Look us up on the website. There's a great architecture white paper. We're going to be doing plenty of stuff in publishing around VDI and other solutions. But I think it's a very interesting architecture for bringing storage